In Lesson 31, Paul used weather data downloaded from openweathermap.org to continue explaining the process of peeling a JSON object like an onion. Our assignment for Lesson 31 was to build a battery-powered weather widget incorporating the OLED and the RGB LED. During Lesson 31, Paul used the DT key to timestamp his weather data. The openweathermap.org documentation describes the DT parameter as the time of data calculation in Unix and UTC. Sounds like it's the time when the online data was last updated. I found it very confusing. I wrote a short program to access DT repeatedly over the course of several minutes, and here's what I got. So you can see that the DT time value increments in roughly 10-minute steps. This will be the as of timestamp for my weather data. After a little more digging in the JSON data, I discovered the icon parameter, which changes with weather conditions. It's meant to facilitate displaying a suitable weather icon on your weather report. OpenWeatherMap.org even provides the icons. Unfortunately, they're not compatible with the SSD 1306 OLED display, so I decided to try and cook up my own icons. It was fairly successful. Some of the icons are static, some are animated, the sparkling sun and twinkling stars and rain falling, etc. There's a link in the description and overhead to a short video describing my approach to creating those icons. The weather report program will display the icon for the current weather conditions. Presently it's overcast in Toronto, so the weather icon isn't very impressive. If it stays overcast, you may never see any of the other icons. So here's a quick peek. The icon value extracted from the JSON data has the number format NNT, where NN is a 2-digit number and T is a text character signifying day or night. I stored the icons I created on the Pico W in a weather icons folder as portable bitmap files with file names in the format nnt-f.pbm, where NN and T are as above and F is the frame number for animated icons or 1 for static icons. Let's look at the Pico code. As usual, we start with imports. API keys and secrets hold data that I don't want to share online. We import I2C and PIN because we'll need them later on. We import SSD 1306 underscore I2C because the OLED will be connected to the Pico by the I2C network. We import network because we're going to be going online. We import time so we can call sleep. We import uRequests because we're going to be using the get statement. And we import OS because we're going to be using the Pico file system. Finally, we import FrameBuff because we'll be blitting graphics onto the OLED. We declare the pins and objects representing the RGB LEDs and turn the LEDs off. We also declare variables that will hold downloaded weather data or control the flow of the program. Current frame number, number of frames, and frame duration control icon animation. Page duration controls how long each of the 5 OLED pages of weather data is displayed. The homegrown weather icons are saved in the weather icons folder on the Pico W as portable bitmap or PBM files. Here we use the list_dir command to load the complete list of those file names into the weather icons on the Pico variable. Weather update interval controls how often we go back to the website for fresh weather data. We set up the I2C parameters for the OLED and declare the OLED display object as normal. Next, we define a function that clears the blue area of the OLED display without touching the area that's reserved for the weather icons. The display page function formats our weather text data onto one of 5 pages. the display next frame function reads and blits the graphic file selected by the logic in the while true loop. Display titles displays text in the top two yellow lines of the display. Get requests can return a success failure status. Status equal to 200 indicates success. Anything else is a problem. So here we declare a function which will display an error message if and when we receive a status other than 200. This section of the program fetches the Wi-Fi SSID and password as well as the API keys for the location and weather gets that we're going to use. Our usual Wi-Fi connection logic follows. If we cannot connect to Wi-Fi after 10 tries, we stop with a message to the user. If we do connect to Wi-Fi, we request our current location from ipgeolocation.io. If the location request fails, we display a message to the user and stop. If the location request is successful, we store the return data in the location variable. Then we concatenate location to the weather URL, display a status message on the OLED, and set the 3 timers which will be used in the while true loop. The while true loop has 3 functions. First one is to periodically download and parse fresh weather data. The second one presents the data on one of 5 pages on the OLED display, showing each page for a fixed amount of time. And the third one displays the weather graphic associated with the downloaded icon parameter and animates it if it's an animated icon. Each of these functions is controlled by its own time variable. If the weather data is older than weather update interval, we get a new download and parse it. Now here I'm experimenting with a more compact logic for the LEDs. Rather than a series of if statements, I converted the temp versus set point comparisons to Boolean values and used them directly in the LED value statement. It seems to work fine. It's more compact, but it also might be harder to explain to somebody or harder to debug. So I'm not sure it's a step forward. Here we parse the icon value and store it in icon from website. Next we count how many times we find icon from website in the file names stored in the weather icons on the Pico variable. Each of those files is a frame for that particular icon. Finally, we zero out the list of icon files list and rebuild it by appending the file name of each of the frames that we're going to display. The logic to display these files or frames is below. If the current page of weather data is older than page duration, we increment the page variable and show the new page. If the current icon frame has been displayed longer than frame duration, we update the frame number and display that frame. Here's the result. The breadboard is battery powered, and you can see the blue LED is lit because the current temperature is lower than 12 degrees C. It's a cool afternoon here in Toronto. This video is long enough. I'll speed this section up just a bit so you don't have to watch the weather report screens change in real time. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.